Welcome to NASA's Jet Propulsion Laboratory in Pasadena, California. It has been an extremely exciting day today, and I want to bring on stage the very successful team for the InSight Mars landing. Let's welcome them now. NASA Administrator Jim Bridenstine, JPL Director Mike Watkins, InSight Project Manager Tom Hoffman, InSight Principal Investigator Bruce Bannert, Marco, team member Andy Klesch, and Elizabeth Barrett, the InSight Instrument Operations Lead. Go ahead and have a seat. I'd also like to acknowledge here all of the InSight team members and the Marco team members who have joined us for the press conference and all of your amazing work for these two missions. We're going to Okay, we're going to start now with NASA Administrator Jim Bridenstine.
Well, thank you. What an amazing day. To start, I want everybody here to know that I've been on the phone recently with both the President and the Vice President, and they are overwhelmingly proud of everything that has gone on here today. They watched the entire thing. Of course, they were very anxious and were anticipating greatness, which ultimately we had today. But what an amazing day, and they are so grateful for all of the hard work of everybody in this room. So I want to start by saying a few thank yous. Number one, thank you to the NASA team and the NASA JPL team. Thank you to the Marco team and the InSight team. We also want to thank our international partners. Today was a great day for the United States of America. It was also a great day for our international partners. Germany, of course, is involved in this mission. DLR has been a great partner, as France has. CNES has been a great partner on this mission as well. I also want to make sure I thank Lockheed Martin, the prime contractor, and we want to thank United Launch Alliance, who actually launched this mission almost 7 months ago from the West Coast, which has never been done before for a mission to Mars. And this is an amazing, amazing day. As the NASA Administrator, this was my first time to be in the room when something like this happened. I've watched it on TV, but really for the first time to be in the room when the data stops and to know how quiet it gets. I mean, it gets really, really quiet. You can't do justice on television with that degree of quietness. And then, of course, once the data comes back, the elation. What an amazing day for me and, of course, the entire NASA team. We're extremely grateful. This was seen all around the world. It wasn't just the American leadership that saw it. Leaders from all around the world saw it. And, of course, populations from all around the world will see it in the newspapers tomorrow morning and, of course, in social media today, online, in the newspapers. So what an amazing day for our country. But it's not just people all around the world that will see it. In fact, people off the world have seen it, and they have some things they'd like to say.
The International Space Station crew would like to come to the inside of Mars itself, and being a really important step on the way there also for human exploration. So kudos for pulling that one off, and we are looking forward to what the data comes out of this mission.
Yeah, Houston copies all and extends our congratulations as well to our partners and friends at JPL. It was really something. Got some goosebumps down here watching the coverage.
Same here.
So ultimately, the day is coming where we land humans on Mars. We're very excited about that. I think that's why our astronauts are so excited about it and why they wanted to congratulate everybody here. With that, I'll introduce the director of JPL, Mike Watkins, who has been the kind of the leader of this organization for a while now. I've known him ever since I was a member of Congress, and I'll tell you, he is an amazing advocate for what you guys do here at JPL, and we're grateful for his leadership.
Thanks very much, Jim. So you guys were lucky enough to be here with us and to share the 8th successful Mars landing in the history of the planet Earth. So you, and I'm very proud as a director of JPL to say that all 8 of those had the press conference right here in this room afterwards. And we never get tired of watching these, so if you don't remember what it was like, we have a little memento here.
InSight is now traveling at a velocity of 2,000 meters per second. 17 meters, standing by for touchdown. Touchdown confirmed. InSight is on the surface of Mars.
So, obviously the InSight team, the international InSight team, put a tremendous amount of effort in, not just working over Thanksgiving holiday here nonstop, but over the past few years. And, all the credit goes really to them. I'd like to give a special shout out to our colleagues at Lockheed Martin in Denver. And we have Lisa Callahan here as the head of Civil Space for Lockheed Martin. Been our longtime partners going back to Viking days in the very beginning. Also like to thank, as was mentioned by Jim, our international colleagues. The incredible scientific payload on this mission could not have been done by any one country in the world. It takes the entire world rather, to build the kind of scientific breakthrough payload that we have on this mission. You'll hear more about it from our PI, Bruce Bannert, later on. But it is critical to our future to have that kind of partnership, and it really means a lot to us. And of course, in the coming months and years even, the history books will be rewritten about the interior of Mars. I personally have to say, the first day, the landing day, and these first couple of pictures of a place no human has ever seen before also remind us that in order to do science, we have to be bold and we have to be explorers. And that combination of science and exploration is something that exists entirely at NASA and at JPL, and we're very proud to be part of it. So, thank you very much. So now I'd like to turn this over to the team that actually did this work, many of whom are out there, but up here, the project manager, Tom Hoffman.
Thank you, Mike. I'm actually truly humbled by this experience. Having the opportunity to work with the amazing team that I've had the opportunity to work with, the team that actually made us successfully land on the surface of Mars, which is never something we should take for granted. It's been a humbling and an amazing experience for me. All the people that are wearing the red shirts and the black shirts today really are the people who made this a success. So I just want to say thank you very much for all the hard work that you put in, and especially all the hard work that your spouses and significant others and loved ones let you put in, because I know you were working on Thanksgiving, but not just Thanksgiving. You've missed a lot of different holidays and important events to make this a success, and today it was all worth it. Yeah. Thank you, guys. So our JPL navigation team and our JPL Lockheed Martin, NASA Ames, NASA Langley team, you guys are now all fired. Your job's over. Thank you for getting us to the surface of Mars. We're going to turn it over now to the surface operations folks. Your surface operations folks, your job has just begun. so you better get some rest. It's going to be a little bit of time before we get the instruments onto the surface of Mars and start getting back this groundbreaking science that we expect to get. But I know, just like the navigation EDL team was successful, I know our surface operations team is going to be equally successful with the support of our international partners. It's going to be awesome. I can't wait to start seeing Mars quakes, start getting temperature flux data coming out of our HPQ. That's going to be truly amazing. This is really the first time I've sat down since we landed. I probably can't sit down much longer, so I'm going to stop talking, or I'm going to start jumping up and down again. So Bruce Mannard is our principal investigator. We have been working together for the last 7 years to make this a reality. Bruce has been working for decades, and I'm so excited for him that he's finally going to start getting his science back that he's been working so long and so hard for. So, Bruce?
Thanks, Tom. Well, I can't tell you what a privilege it is to be up here today. People keep talking about, my science and my mission, but this is really something that we're doing as a science team for the world. I mean, the science that we're doing belongs to everybody, and the knowledge that we're going to bring back is going to belong to everybody. So we actually have a little bit of science already, thanks to our friends at Marco, who sent down this first image. It's nice and dirty. I like the nice and dirty image. So we can see the surface of Mars, and I'm just taken back to 1976. I was actually a student intern here at JPL in the summer of 1976, and so I never actually got to come into this room while the press conferences were going on. But I was just outside, and I would sneak in here in between and just look at the place and just wonder at the history being made. And that first image from the Viking lander, that bright red image. We'd seen all these nice black and white images from the moon, and they were amazing. But this bright red image from Mars, and the first image from another planet, and now I'm looking at this image from InSight, and it's just it's like a full circle of a whole career working towards understanding Mars better. We have a little bit of some things in this image that you can see. You can see a rock in the front. If we can go to the next image, there's actually a couple of other things. We can actually see the bolts that are holding this dust cover on. This image is actually a very good argument for why you put a dust cover on a camera when you're landing on Mars. Good choice, right? So all those black specks are going to disappear, and when that goes away, you're not going to see those little cover bolts down there in the bottom right and left. But you will see that the lander foot pad, and we'll be studying that in the next couple of days. Looking at the amount of dirt on it, looking at the kind of dust, trying to figure out what the distribution of particle sizes and all this kind of stuff that's really critical to putting our instruments down on the surface. And up there in the upper corner, you can't even see it in this picture. It's so dusty on the edge, but that's the storage box that holds the tether, the cable that's going to connect our seismometer from the ground of Mars up to the spacecraft where it can beam the data back to Earth. And so if you've been paying attention, you know that you're not supposed to be expecting any seismology to come out of us anytime real soon, but we're going to be spending the next couple of weeks looking at that ground and finding exactly the best place to put our seismometers down. It's a very, very nice looking picture. It looks pretty flat. We're very level. I think we're less than 2 degrees of tilt, which makes our job very easy to do. It's time to get going.
Let's do it.
So you all saw the excitement in the control room, but actually there's been excitement all over the world, and we got some images back. If we can roll some of those images now, we've had people watching all over the world, all across the United States, Europe, Asia. They said they were going to roll some pictures behind me. I'm not seeing anything coming up, but take my word for it. There's a lot of people cheering all over the place. Here we go. There we go. There's some of the pictures. I really wasn't paying that much attention to what was going on after we landed because it was such a crazy time. But we've got people people and animals all over the place. We've got hundreds of people. There have been museums that open up their doors for this, auditoriums in Times Square. The NASDAQ screen on Times Square was there, and there were an amazing number of people out there in the snow and cold watching InSight land, and even at the Air and Space Museum here, or at the Science Museum here in Los Angeles. And so it's just been a wonderful event all across the world, and I'm just so proud and so privileged to have been part of it. And with that, I'm going to turn it over to Andy Klesch here, who was on the Marco team, who brought back that wonderful image for us.
Thank you very much. So this has been a fantastic day for spacecraft, great and small on the way. And our spacecraft are very small. Only the size of a briefcase, or really carry-on luggage. We were able to take 2 spacecraft, have them transit 301 million miles over the last 6.5 months, and have them fly by Mars. Now, this was not only a very small spacecraft, but it was built by a very small team that we actually have, and you can see them over here on the side. This team of really mostly part-timers on the project has proven the technology that we were trying to demonstrate with this mission on here, being able to support a large craft like InSight in order for it to perform its fantastic science, being able to show that we can take a smaller, focused, more riskier mission out into the solar system and try and perform new opportunities, or take advantage of new opportunities that we have, and try and bring the community that we have built for these small spacecraft along with us. Early on in the mission, we had interns from University of Michigan actually build parts that are flying in Marco right now. The primary flight computer that's flying there was built from the University of Michigan. We had students from Morehead State University actually receive some of the first data back from Marco back in the May and June timeframe. And we have 2 interns here representing their school from Cal Poly San Luis Obispo that were serving on the operations panel there and bringing back the data for InSight today. And it's all of these different schools, it's the broad community that we have that really made Marco such a success. Now, Marco was there to relay information back from InSight in real time, and we did that extraordinarily well. We had no drop frames, no drop data along the way, and we tried to bring back the image that you had to kick off your science. But on board Marco itself, we had one more gift that we can give the InSight community, and if you bring up the next image here. This image was taken from Marco. Having successfully brought all the data back from InSight during its exciting entry, descent, and landing sequence, what you see before you is an image taken roughly 4,700 miles from Mars at about 12:10 p.m., 10 to 15 minutes after EDL itself happened. And this image is really our farewell to InSight, our wish for good luck, and our farewell to Mars itself as we continue on to complete our primary mission as part of Marco. So we thank you for all of your excitement. We thank everybody who helped out in the Marco project, and we look forward to all the science yet to come. To tell you a little bit more about what's next is Elizabeth Barrett.
Thank you. I had the privilege to watch the landing with our science and instrument teams on InSight, so it was amazing watching with the scientists and the engineers that have devoted many years of their life to watching InSight land and see it actually land successfully. And now that we're on the surface of Mars, we have a lot of work to go. So now that we've landed, we start an initial assessment phase. So the first thing we'll do is assess the health of our spacecraft and then the health of the instruments that went with us, and then look at our landing site. We've got the first picture down, very much thanks to Marco, and now we want to look at it in more detail and understand where can we place the instruments on the surface to get the best science return. Once we make that assessment, we start our deployment phase, and I believe we have a video to accompany that. So the first thing we do is we're going to deploy our seismometer, or SEIS, to the surface. Once that seismometer is down on the ground, we make sure it's in a good location, that it's working well, that we like its placement, and after that, we will return to the deck to grab our wind and thermal shield, or WTS, that goes on top of the seismometer to protect it from the environment. So the wind and thermal shield is deployed directly on top of SICE to protect it. And you can see here we're lifting it up. You see the skirt drop down. That's going to help protect SICE from the environment and being placed directly on top. Once we've deployed WTS successfully to the surface, then we return and we pick up our heat probe, or HP cubed. And we're going to deploy HP cubed to the surface as well. And after we finish the deployment of all our instruments, making sure they're all in a good location, all in a good state, then it begins the last portion of the mission before we can actually do the full science return. We've got to do the penetration of the mole of HP cubed underground, going up to 16 feet underground. And then we also do commissioning of our seismometer, fine-tuning it so that it can detect all those very subtle vibrations on Mars to get that great science return. This entire process, just getting the instruments to the ground, takes approximately 2 to 3 months. So it's going to take a little bit of time to get to that point, and then another couple of months for the mole to penetrate through the ground and to do the fine-tuning of the seismometer. And at that point, we'll be sitting back and listening for those Mars quakes and measuring the vital signs of Mars, getting all that great science return. We're really looking forward to that. And back to you, Ron.
Okay, we're going to open it up now to questions. We're going to be taking questions from the phone line. If you are on the phone line, you need to hit *1 to get into the queue. We will take some questions from here in the room and also from social media. Just submit your question, post your question with #AskNASA. I will start with a question on the phone, and then we'll go to the room. On the phone, we have NBC. Please go ahead.
Hi, this is Denise. Can you hear me?
Yes, we can hear you.
I was wondering, this is a question for Andy. I was wondering if you could explain what happens to the 2 Marco spacecraft, and also whether this technology concept could be used on future missions and how. Thank you.
Sure. We're looking forward to seeing the end of Marco's primary mission. We have roughly 2 more weeks to bring the rest of the data down from Marco, covering the entry, descent, and landing sequence and all the lessons that we've learned from the voyage thus far. At the end of those 2 weeks, the 2 Marcos will continue on an elliptical orbit around the sun on here. And that is really the end of our initial period. Though because of the success of the Marcos thus far, we are discussing with headquarters on what we might do with them next, including evaluating their survivability and seeing what other great science and lessons that we can pull from those craft. We do look forward to these lessons being used on future missions. There are many future small sats and CubeSats that are in work and funded by NASA at this point. And we look forward to more concepts into the future.
Okay, I'm going to go to a question here in the room. Steve Futterman, go ahead.
Congratulations, all of you. I want to ask a question to Tom and to Bruce. Tom, we've talked to people in this situation before. The last few moments and immediately afterwards can be very, very emotional. I'm wondering if you could talk about what was going through your heart and mind, how emotional it was for you, and then I have one for Bruce.
It was an incredibly emotional experience. To think about working for 7 years, as many of the people here in the room have done, to get to the point where you have 7 more minutes to survive, literally survive, is incredibly hard to describe. My heart was basically, I think, just stopped beating for 7 minutes. I don't know if that's healthy or not, but then when we got the indication of parachute deployment, which was absolutely terrifying thing to think about, we got that positive. And then listening to Christine Soleil call out as we got closer and closer to the surface, every time she made a call out, you know, the hairs on the back of my neck would start rising a little bit higher, a little bit higher. And when we finally got the confirmation of touchdown, it was completely amazing. The whole room went crazy. My inner 4-year-old came out, but it was not bad. Some of the people on the team had made a timeout area for me just in case. I didn't have to use it. But it was an incredible, incredible experience, and it was amazing.
And Bruce, I'd like to ask you, can you give us an idea of 1 or 2 questions you'd like to see? I'm sure there are lots of questions, but 1 or 2 at the forefront that you would like to see this mission maybe answer or give you hints to the answer?
Okay, so this is going to get kind of nerdy, but
good, that's good.
But When I was here in 76 and in the next summer in 77, I was working on a project that was looking at the deformation of the Martian surface and how the surface is pushed down under volcanoes and volcanic provinces on Mars. And I kept on running up against the problem that I needed to know the thickness of the crust, because that affected the gravity field, and the gravity field was one of our basic measurements. And so we just had to kind of fake it because we had no idea. So we kind of say, well, it has to be at least this thick and that, but it was just a bunch of, blah, blah, blah. Honestly, and I thought, gosh, I really...
That's a scientific term, by the way.
That is, yes. Only 3 blahs, right. So I was like, I just need the thickness of the crust. If we only had a seismometer there, it would be like a snap to get the thickness of the crust. And so that's one measurement that I would like to go back, get that old paper, plug it in to see how close I was. So that's one that personally I'm really attached to. And then the other thing that really kind of interests me, even though it's not really my particular field of expertise, is the properties of the core. I mean, the core of Mars is a really fascinating object, and it has tendrils into so many aspects of the Martian evolution and even the evolution of the habitability of the surface in terms of the magnetic field, in terms of the amount of heat coming out of the interior. And so when we start getting some information about the core, which obviously is kind of like the hardest thing you can do, is actually go down to the very center of the planet, through 1,000 miles of rock, and actually figure out, what's this made out of, or how big is that? That's the other kind of piece of information that I'm really looking forward to understanding better.
Okay, we're going to take one more from the phone line, and then I'll come back to the room. We're going to go to the AP next. Go ahead.
Yes, hi. Can you hear me?
Yes.
I'm wondering, how close to a bullseye did you get on the landing site, and is there any way to gauge how big that rock is in the foreground of the first picture?
Yeah, so we got very, very close to the bullseye. I don't have the final numbers, but we are very close to the bullseye. That rock, actually, I'm really happy about where it is, because it's not where we intend to place the instrument, so that's great. And if you look at it closely, it looks like there's a little bit of sand that's been moved away from it, either by the descent engines maybe, or by wind over time. Either of those is great, because what that means is the area in front of the lander is likely mostly sandy soil, which is going to be great for the HP cubed instrument.
Okay, we're going to go back into the room. Let's go on this side. Emily, if we can get a microphone right there. Thanks.
Hi, Emily Laktawala with the Planetary Society. A detailed question. Do you know how large the pebbles are that you can see in front of you? And then a question that I keep getting asked by people online is, how many impacts do you hope to be able to detect during InSight's mission now that you're on the surface?
Okay, I haven't really had a chance to look at this image in any detail, and it's kind of difficult to judge the size of things because this is a fisheye camera, so it's a very distorted view. It's actually showing almost the entire area in front of the lander, kind of compressed into a narrower image. And so we have experts on the team, I'm sure, are already poring over this, and in the next day or so, we'll have some measurements of the dimensions of some of these rocks. And what was the second question again?
How many impacts?
How many impacts? Well, of course, that's one of the things that we want to measure. Our estimate is we should probably see something like maybe a half a dozen impacts, maybe twice as many of that, maybe half as many of that, but somewhere in the order of a half a dozen to a dozen, I hope.
Okay, we're going to take the question on this side.
Thank you very much. Tariq Malik with Space.com, and I think my question's for Bruce or for Tom. We see a lot of excited people here in the room that worked on the mission. I'm wondering kind of what comes next. Is there a party? If so, when? And does everyone get the night off, or when do they hit Mars time for InSight? Thank you.
Yeah, so for the folks that I just fired a little bit ago, the NAV team and the EDL team, they're welcome to go off and have a celebration. But the surface operations team, actually their work is just going to get started when we get the Odyssey pass a little later this evening. That's when we're going to start planning for the next sol, the next day. Sols on Mars, days on Earth. We'll start planning for that next sol, and maybe Elizabeth, you can tell a little bit about what are some of the things we're going to be doing the first couple of sols.
Yeah, so the first couple of sols, we are going to assess the health of the robotic arm, and then tomorrow we uplink checkouts for the actual instruments themselves to check them out and assess their health as well. So in addition to obviously monitoring the lander and making sure those solar arrays have deployed, we want to check out all the instruments that have gone with us to be prepared to put them on the surface and to collect all that science data. Over the rest of the week, we also will open the covers on the cameras and do a more detailed survey of the workspace in front of the lander where we want to put the instruments so we can choose the best places for them to go.
Okay, right there in the center aisle there.
Hi there, Margaret Carrero, KNX Radio. Very exciting to be here. It was my first time. And we talk a lot about, this I think is for Tom and Bruce as well, looking into the interior of Mars. Why should we all care about this? I know it's exciting, but why should we all care? What do we expect to get out of digging into Mars?
Okay, so the reason why we're digging into Mars is really just to better understand not just Mars, but the Earth itself. And so one of the things I think that is a source of our natural curiosity is, how did we get to where we are today? How does this planet that's under our feet, how did it form? How did it get to be a place with, mountains and oceans and breathable air and things like that? And we're trying to go back in time to the very earliest stages of the formation of our planet. And we're looking for evidence which is no longer available on the Earth. It's all been erased by plate tectonics, by mantle convection, by our active geological processes that are eroding everything. And so the sort of the fingerprints of those early processes just aren't there on the Earth. We can go back to Mars. On Mars, all those things that were formed in the first few tens of millions of years after formation are still frozen in place. And so we can basically use Mars as a time machine to go back and look at what the Earth must have looked like a few tens of millions of years after it formed. And by doing that, we can then look at our physical models, our theories of how the Earth evolved and understand why the Earth became the way it is. If you look at Earth's twin, Venus, it's almost the same size, but it's an extremely different surface environment. It's very hot. The atmosphere is very sulfurous. There's not much oxygen. And yet, why is it different than the Earth? And we have some theories about that, and they generally have to do with very small differences in the way the planets evolved from that initial state. And so Mars will help us refine our models, understand why a planet might go one way like Venus or the other way like the Earth. And finally, when we actually look at planets around other stars even, we can actually begin to estimate which ones might be habitable and which ones maybe not habitable based on some of the geophysical understanding that we'll get just by looking at Mars.
Okay, I'm going to go to the phone line now, and then I'll come back in and check in with social media. Okay, let's go to the phone line. Irish TV, go ahead.
Oh, thanks very much, Veronica. I'm actually in France at the City of Space, the Cité de l'Espace in Toulouse, where there was a huge crowd watching this event for obvious reasons. And when the first picture popped up, a couple of questions came to mind. One for Tom. Are you proud of yourself that you have managed to land in the most boring place that anyone has landed on Mars in history? And for Elizabeth, are you embarrassed that it's going to be, apparently from these pictures, so incredibly easy to place the seismometer on the surface?
I'm very, very happy that it looks like we have an incredibly safe and boring-looking landing location. That's exactly what we were going for. It's what the landing site selection people promised me. They promised me sandy with no rocks. There's one rock, so I'm going to have to talk to them a little bit. And there's certainly some small rocks, but those look pretty manageable. It's hard to tell in this picture, though, how easy it will necessarily be. You can't tell if there's any slopes or anything. We expect to get that later, but it does indeed look to be pretty much like a parking lot. I think Elizabeth's still going to have her job cut out for her, but I'll let you answer that question yourself.
Yeah, it was actually great when the image popped up in the room with all the science and instrument experts there. Everyone gathered around the very front and was immediately deciding where could we place instruments and where were the rocks in the way. And it's amazing. That is actually so nice, and it appears to be quite empty. As Tom said, we have some more assessments still to do to make sure it meets the requirements for where we can put the instruments at our default locations or in changes we have to make to go to a new location. But this is a great indication. We were all certain that that first image would help us determine how difficult of a job we would have in placing the instruments, and I'm very happy that it looks like we'll be able to do it quite easily, we hope.
Okay, let's go to social media. Do you have some good questions there, Stephanie?
Absolutely. The internet is exploding with questions and joy. They're almost as excited about the landing as they are about the epic handshake in Mission Control. So we are getting a lot of questions about the cameras and the lens covers in particular. So how long till we remove the lens cover, and will it be permanently removed, or will it be able to go back on during a dust storm?
I think you probably...
Yeah, so the lens covers, once removed, are permanently removed. They cannot be put back on. So once we pop them, they are popped off entirely. I believe the first cover we open on Sol 2. So right now we're Sol 0, and a Martian day is called a Sol. So on Sol 2, we should open the first cover, and on Sol 3, the cover for the second camera. So this week.
Fantastic. And Janice Winston would like to thank all of you for making her birthday a very exciting day. And for the administrator, she asks, how long do you estimate it will be before we land a person on Mars?
Oh, wow. I'm going with the mid-2030s. That's very aggressive. But here's what we're doing. We're going to the moon. That's part of the president's first space policy directive, to go to the moon. But he wants to go in a way that we've never done before. This time, we're going to go to stay. So we're going to build a sustainable architecture. In other words, we can go back and forth again and again with landers, with robots, with rovers, and even with humans. It's going to be an open architecture. So we know what happens with reusability. We've seen that with the cost of launch and the access to space with reusability. Cost goes down, access goes up. Well, we want the entire architecture between the Earth and the moon to be reusable. We want launches to be reusable. We want tugs from Earth orbit to lunar orbit to be reusable. We want a reusable command module in orbit around the moon. We call it Gateway. And we want reusable landers going back and forth to the surface of the moon over and over again. The entire architecture needs to be reusable. It needs to be open. In other words, the way we do data, the way we do communications, the way we do docking, all of it is open and available to the public. Once we achieve that, then we can have international partners and commercial partners join us, and ultimately we can build an international coalition of nations to have a sustainable return to the moon for the long term. Now, the reason that's important, here's what we know about the moon. It's a 3-day journey home, which means if something goes wrong, we can still come home. We've seen that with Apollo 13. So we have a perfect proving ground that is part of the Earth-Moon system. The moon never leaves the Earth. Mars is a whole different ballgame. But what we can do is we can prove technology, we can retire risk, and ultimately prove human physiology, which is a whole other dynamic that we're working on the International Space Station right now, and then take all of that and replicate all of those capabilities and technologies as much as possible for a trip to Mars. Now, we talk about the Gateway being that reusable command module. We think back to Apollo. We're all so proud of Apollo. What an amazing accomplishment Apollo was. The entire thing was thrown away except for that tiny capsule at the top. So what we want to do now is we don't want to throw away the whole thing. We want everything to be reusable, or at least as much as possible, so that the mission is ultimately sustainable. If we can achieve that, and we can replicate as much of it as possible for a trip to Mars, we talk about Gateway being a reusable command module in orbit around the moon for 15 years. The first Gateway is all about discovering more about the moon than we've ever discovered before. Solar electric propulsion, it can go to the L1 point, it can go to the L2 point, it can get us to more parts of the moon than we've ever been to before. Think about the moon. 2008, India made a discovery that there's potentially a lot of water ice on the surface of the moon. 2009, we definitively know that there's potentially hundreds of billions of tons of water ice on the surface of the moon. Water ice represents life support, air to breathe, water to drink, but it's also hydrogen and oxygen, which is rocket propulsion on the surface of the moon in hundreds of billions of tons. So we talk about in situ resource utilization capabilities on the moon. We can prove a ton of stuff on the moon and accelerate, once we've done that, accelerate the trip to Mars. The first command module, we call it Gateway, is a reusable command module around the moon to get us to more parts of the moon than we've ever gone to before. Remember, definitively, we learned in 2008 and 2009 that there was hundreds of billions of tons of water ice on the surface of the moon. We need to be able to get to more parts of the moon than we've ever been able to get to before to learn what we don't already know about the moon. But while we do this, we're proving capability and technology to go to Mars even faster than we could go if we didn't use the moon as a tool. So the reality is, yes, your nation right now is extremely committed to getting to Mars and using the moon as a tool to achieve that objective as fast as possible.
Okay, we're going to take another question here. Stand by with social media. Let's go back here. Can we get the microphone? Thanks.
Thank you. Irene Klotz with Aviation Week. I think this is for Andy. Can you describe a little bit about what other data is going to be coming back from the Marco satellites that you didn't get back already? And is there any consideration to putting Marco-type satellites on Mars 2020?
The data that's coming back from Marco really does a deeper dive into what we recorded on board in terms of the health of the spacecraft itself. During EDL, we were focused on getting that InSight data down, so we had just a very narrow pipe that we could put a little bit of information about Marco, about its temperatures on board, about the energy that it was using, how well it was oriented, and how well it could support the data coming from InSight there. We'll be collecting more in-depth information about the spacecraft itself. We'll look at the trajectory that it actually flew by, how stable it was. Actually, the orbit determination was quite good on Marco on there, so that tells us how well we were able to fly by Mars and prepare for that journey there. And all of this is really stored in onboard memory that we'll be slowly bringing down, as well as, if possible, more images that we took during today's events on here. Now, on top of that, though Marco was set to support the InSight lander, Marco A passed through a very unique trajectory behind Mars, so we actually were occluded or blocked by the planet with respect to Earth. And so with that, we're actually doing atmospheric science as we're passing by Mars on there, and we'll be digging into that data as well over the upcoming weeks. So not only did we do technology demonstration, not only were we able to get images back, but we are able to do some science there as well. As for things into the future, we've shown that this type of craft can support these types of missions on here, should that mission need it. And we'll be looking at opportunities as we go to see where they're necessary and how well we can support in the future.
Okay, going to this side of the room, right in the back.
Hi, Sophie Sanchez, Cosmic Chicago with Chicago Now. My question's for Jim. The last time we spoke, you mentioned that NASA was prioritizing human spaceflight programs to avoid any gaps. Like we're experiencing now. My question is, what is the agency doing to avoid any gaps in planetary missions?
So that's a great question. What we have to do as a country is we have to look at a portfolio of planetary missions. And of course, some missions are what we would call, flagship missions, very big, large, expensive missions. And other missions are not so expensive, but very capable. And so what we're trying to do is figure out what the right balance of portfolio is. If every mission is a flagship mission and they fail, then that's a lot of money and a lot of time that ultimately we don't want to put all of our eggs into one basket. So we're looking at creating the most balanced portfolio that includes small missions and large missions. I think a perfect example is New Horizons, which, of course, we're all familiar with the 2014 flyby of Pluto, and now it's no kidding, in the Kuiper Belt, and it's going to be taking pictures of Ultima Thule here in just a matter of a month from very close range, which has never been done before. And that was a mission that was, you look at return on investment, it was a tremendously inexpensive mission for the amount of science and data that we're getting from it. So I think we need a good balance of portfolio that includes high-end kind of missions that are what we call flagship missions and others that are smaller to keep that balanced portfolio. To be clear, we want to make sure that the planetary science missions, the heliophysics missions, astrophysics missions, earth science missions, all of those are balanced across the entire portfolio and balance those missions with human missions. The key is to create a balanced portfolio to get as much science as we can from our agency.
If I could just add one thing to that. You're all invited back in about 26 months for the landing of Mars 2020.
There you go.
So we are avoiding a gap.
Hi. Fred Bastien for Fred Bastien YouTuber channel. My question is for Elizabeth. You've demonstrated how the instruments are going to pan out with a video. You spend a lot of time on this in the next few days and weeks. Exactly how long is deploying all the instruments going to take, and what are the biggest risks of that process?
So the first couple weeks, we actually just are doing the initial assessment of our deployment area, and then we begin the deployment itself. To get all the instruments on the ground is expected to take approximately 2 to 3 months for final deployment, at which point we can then start the penetration with the mole and the commissioning. So we expect approximately 2 to 3 months. I liken it to a game of playing that kind of claw game at a carnival, but you're doing it with a really, really valuable prize, and you're doing it blindfolded where you can only get occasional pictures, and then you're doing it via remote control on another planet. So it makes it a little bit longer. You need to take more pauses to make sure you actually have the grapple on the payload before you lift it up, and it's actually on the ground before you let it go. So you want to take those pauses along the way to make sure everything is going well. So it's expected to take that duration to allow us to have those breaks in the process. In terms of what we need to do, I think the biggest thing is choosing our final deployment locations and just making sure we practice that a lot. We have a test bed here that we actually will terraform to look very much like the Martian area we land in, and we'll practice deploying to make sure everything is going to go smoothly.
Any more questions in the room? Yes.
Sorry, with apologies to the InSight team, I'm going to take advantage of the opportunity to ask Mr. Bridenstine another question about the future of Mars exploration. There isn't another Mars mission on the books after Mars 2020. What are NASA's plans to get started on Mars sample return and maybe to replace our aging telecommunications orbiters that are up there? Or not replace, but improve upon?
No, the two critical issues. The sample return of, Mars 2020 is going to cache samples on the surface of Mars. Now, it would be silly to cache those samples and not return them. That's the goal. So after Mars 2020, we need a sample return mission, but you're absolutely right. With all of these very successful missions on the surface of Mars, to include not just Mars 2020, but one thing that I know Chairman John Culberson has been so committed to is the Mars helicopter, which has a lot of people so excited. The idea that we're going to fly a helicopter on another world for the first time in human history with the Mars 2020 mission. With all of these activities, you're right, we're going to need more communication architecture around Mars. So the answer is we're putting together budget requests right now and presenting them to people within OMB and within the White House to be prepared for the day when we can go to Mars with even more missions. It's a high priority for us. We don't, NASA has a long history of building upon the last success. And that's ultimately what we want to do here.
Okay, we're going to check in with social media. Stephanie, do you have any more good
Absolutely.
questions?
So a simple one. Ethan Plant would like to know how much time was spent planning the InSight mission.
Wow. Wow. Well, you may or may not be able to see the number of people that are around in this room, and that's just probably only half or so of the people that have worked on it, probably on average for 4 or more years. And so you multiply that all out really quickly in your head, which I can't do. One of our navigators already did it, and probably to the 14th decimal point. But it's a huge, huge amount of work that's gone on both at JPL and all of our partners and our international partners to make this a success. And there's still a lot of more work to do. As Elizabeth pointed out, we've gotten just part of the way done with this mission. We maybe got the hard part out, but there might be some challenges still in getting the deployment done. So there's a lot more time to go and work to be done.
Yeah, in terms of planning this particular mission, I would say, we were probably sitting down in a room and sketching out about 10 years ago trying to get together the ideas for the proposal that finally became this mission eventually. So I would say about 10 years we've been planning this. On some level, I've been planning this for almost 30 years because, back in 1988 or so, I've started working with some engineers here at JPL to try to develop a seismometer to go to Mars and trying to figure out the kind of mission that would carry it. And so depending on how you want to calculate it, it could be 30 years, it could be 5 years, or it could be a couple of thousand years as Tom was going to do it.
And for Mike Watkins, Cool American Adventures from our YouTube chat would like to know if you had one dream takeaway from this mission, what would it be?
My dream takeaway, I think, of all of these missions is just to remind us to be bold and remind us to keep taking challenges and keep moving forward and never to be scared of these kind of challenges. I mean, it's what we do. You have to take these chances to go forward. We've been lucky enough recently to be very successful, but it's still a risky business, but you have to keep moving forward and you have to keep trying these things. We try them on Mars, we try them on Europa, and we try them all around the solar system, and it's something that I think is part of human nature, and it's something that challenge we have to keep taking.
All right, and with that, I think that's an outstanding closing statement for today's news conference. Now, before we're going to do a replay of images for media. If you want the replay of images, we'll do that in just a couple of minutes before we close out. But I know that there are some team members here who wanted to come through and do their high fives. So come on through, gang, and this is